So experiment number 3. So this is studying of IP addressing. In this experiment, we are going to discuss some of the topic. So these are the topic name. So we are going to discuss about the classification of IP address, because there are 5 types of IP address. And then we are going to discuss about, of course, this is class 4, that means the classification, and also another one which is called classless IP address. We are also going to discuss this one, that what is classless addressing, and another one is the subnetting. Although we are not going to do supernetting, we are going to discuss about the subnetting. So these are the topic we are going to discuss in this experiment number 3. Okay, as far as you know that everyone, we know that the IP address we are using for our different types of devices which is connected to the internet, that is 32 bits long, like this. So in this IP addressing, we have 4 parts. Decimal part, whenever you write it in decimal, it's like that, 128.11.3.31. We know that we are separating these 4 numbers by using a dot. And if you convert each of the part into the binary number, right? We have 8 bits of binary number for each of the block. That means for the first block we have 8 bits. For the second one we have another 8 bit, third one we have 8 bits, and the fourth one we have 8 bits. So altogether we have 32 bits long IP address. Okay, so each one has 8 bits binary number. That's why each of the block is called octet. All right, it has 8 numbers, that's why it's called octet. So this is octet number 1, octet number 2, octet 3, and octet 4. So next time we are going to call them as octet. Okay, octet number 1, 2, 3, and 4. Fine, because each of the decimal number is represented by the 8 bit of binary number. All right, that's fine. Another thing is the version. We know that this is IP version 4, right? And the IP version 4 is 32-bit long. So if you have 32 bits of numbers, how many combination is possible? 2 to the power 32, right? 2 to the power 32 different types of combination is possible. That's why if you calculate 2 to the power 32, it will be this number, that many big number. If you think about this number, this is actually 4,294,967,296. That means we have 4.5, oh sorry, 4.3 almost billion number of IP address. Okay, all right, I hope you know about the IP version 6, right? IP version 6, what is IP version 6?
So, actually, it is 128-bit address and human bit.
Exactly. So why we have IP version 6 address? Why we have IP version 6?
Because the limitation of IP version 4.
Exactly. We have a limitation of IP version 4 because we have so many devices. That's why we have another version which is called IP version 6, which I have already shown you in the last class. So that is IP version 4 and IP version 6. Now let's see about the classification. We know that we have 5 different types of class, right? Do you remember this, the classification? Okay, it's based on, it's based on the first octet. So the decimal number of the first octet, based on the number, we can have 5 different classes. Although last 2 classes are not usable for us, they are reserved and they are unused or restricted for specific reasons. Okay, all right, so we are using generally A, B, and C, and you can see that 0 to 127, 128 to 191, 192 to 223. So these are the range. So it's better you remember at least class A, B, and C, because most of the time whenever you use the IP address is actually either class A, B, or C. Let me show you one thing. I don't know I have shown to you or not. let's say for example we are going to ping Facebook. Ping facebook.com, enter. Look what is happening. I was pinging Facebook. Look what happens pinging Facebook. In the bracket, this is an IP address. 31.13.66.4. If you ping to the Facebook, it can be a different number, because in the morning I have pinged the Facebook. By the way, this is not Facebook. Wrong address. Yeah, now this is Facebook. Facebook. All right. Now this is Facebook. if you ping the Facebook, you can see there is an IP address 31.13.66.35. If you ping, I hope that your ping will be your IP address will be different. Let's ping. If you are in front of your laptop or PC, just go to the command prompt and just write this one, ping and facebook.com. You can see that you will find one IP address, this one. This is the IP address of Facebook, although it is not the same, maybe not same for you also. Maybe your IP address of the Facebook can be different. Okay, so what do you think this IP address? Which class? Class of the IP address? This one? 31.13.66.35. Which class? Come on, it's class A. Until 127, it is class A. All right. Either it's a class A, class B, class C, D, or E. So based on the first octet, is the decimal number of the first octet. That means the first number is 0 to 127, right? So that will be class A. For example, you have a number of 127.255.255.1. That is obviously class A address. So the last address of class A is 127.255.255.255. That is the last address of class A. If you think about the first address of class B, it will be 128.0.0.1. That will be the first address of class B, because it started from 128. So what will be the last address of class B? 128. Last address.
191.
No, the last address. I mean, not 128. Sorry, 191 dot 255 dot 255 dot 255. Right? That will be the last one, right? These classes will be considered when we are using class full address, this one. As we know, there are two types of IP address, or we can use our IP address in two different ways. One is the class full, where we consider the class. Another way, we actually don't consider about the class. That is called classless address. Okay, so in this case, we are considering class full address. Okay, maybe today we don't have time to discuss about the classless address, but maybe next class. So this is always remember about the class full address. Okay, all right. Another thing I think we have discussed earlier about the network portion and the host portion of any IP address. So we know that in any IP address, we have any IP address, any valid, of course, any valid IP address can have two different parts. One is the network portion, another one is the host portion. Okay, so depending on the class, again, this is true. Remember, this is true for class full address. Now we are discussing about class full address. Do not confused when we discuss about the classless address. Okay, so that is the different case. So in class full address, we have two parts. network part and the host part. I hope you know what is the network part, right? What is the whenever we say that an IP address has two parts, network portion and the host portion, what do you understand by the network part or network ID of an IP address?
Basically, sir, two items are one component that is the identity and most part is the how many users are used
Yeah,
these networks.
yeah, correct, correct. It's actually a group of address, right? An unique address of a group of computers or a group of address, right? So that is very similar to our mail address. We have road number 10, right? So whenever we are saying road number 10, so we are actually referring that in road number 10 there are so many houses and all together they are road number 10, right? Then we go for the house number. Very similar here. Whenever we are having a group of address, we call them as network address. By watching or by checking the IP address in the class full IP address, we can identify which part is the network address and which part is the host address. Okay, very simple, very simple. That if you think about the class full address, then for class A, the first octet will be considered as network ID and the rest of the three octet will be considered as host ID. Okay, in for class B, for the first two octet will be considered as network ID and the rest of the two parts or the two octet will be host ID. Same as class C, for the first three octet will be considered as network portion and the rest of the octet will be considered as the host portion. Fine, so network part and the host part. Let's say for example this is an address. Which class it is?
So class three.
Class A, right? Class A because it is starting with 14, so we consider that yes, this is class A. So if you think about the network portion, let's consider this is a class full IP address. By the way, let me tell you how you can identify by looking at any IP address. How do we know that this is a class full address or classless address? By the way, this is the example of class full address, right? So we can consider the conventional class if in this IP address. But if you have this kind of address, let me show you. For example, where are you? Come on. Let's say, for example, here, this one. Look at this one. We have an address where we have an extra two numbers with slash. So slash a number. In that case, we actually consider that yes, it can be a classless address. Okay, most of the time. Because the slash means something, slash a number means something. Okay, that's how we actually can get an idea of this is a class full or classless address. Another example is this. So if you look at the IP address, if you compare the IP address with our conventional class full IP address, which class it is? 67, 99, 170 and 80. What is the class? Come on. Class C, right? Or class B?
Yes,
Class
sir.
B.
Yes.
Class C, sir.
Class C.
C, sir.
Class
Class C,
C.
No, no,
Okay.
no. Class B. Class B.
Class B.
Yes,
Actually,
sir.
class C will start from 192, right?
yes, sir.
192. So it's actually 167. So obviously this is class B, right? So for class B, how many network address we have? I mean, how many bits we have for the network address for class B? 16 bit, right? Oh no, they're not this
Yes,
one.
sir. 16.
16 bit, this one, class B. we have 16 bit of network address. That means our network address for class B is 16 bit. But look what they have written. It is says /27. It is /27. So we assume that if it is a class full address, we assume that this is class B, so the network portion will be 16-bit. But this is not a class full address, this is a classless address. That's because we have a slash a number 27. So whenever we see slash a number, that means that number represents that this is a first thing, it is a classless address. And second thing is how many bits are for network address. In this case it is written 27. That means from 32 bits from here, 27 bit will be the network address and the rest of the 5 bits will be the host address. Do you understand the difference between classful and classless? Let's consider this is the IP address. Okay, let's consider we don't have this portion. So if you just look at this IP address, it is very similar, it is very simple, that it is 167 199 170 and 80. This is obviously this is class B address, and we know that the network portion of class B is 16-bit long, right? 16-bit long. So we assume that okay, the network address will be 16-bit long. But this is really not class full address, this is classless address because we have a slash and have a number. That means it's a classless address, and after the slash, whatever the number is, that actually represent that how many bits is associated with the network address. In this case, it is written 27. That means we have 27 bits of network address, and the rest of the bit, remember bit means in the binary number, don't think about the decimal number, right? So you have to convert this one into decimal, and then you have to find out what until which point you have the network address. So until 27 bits we have the network address, and the rest of the 5 bits will be host address. So that is the difference. So don't get confused and be very careful to identify the classful and classless address. Fine, we will discuss more, don't worry, we will discuss more about the classful and classless address. Okay, but for now let us be very sure about the classes of IP address, about the network portion and the host portion. All right, any questions so far? About the subnet mask. So let's consider what is the subnet mask, or what is the default mask. Mask is, we already know that which part is the network portion and which part is the host portion. So we have a network mask or subnet mask. You can see if you look at this one, see this is the mask. Every IP address is associated with one mask. All right, sometimes they call it subnet mask, they call it just mask or default mask. Okay, so what is the mask? Mask is, or how to identify the mask. The mask is whenever you convert everything into the binary number, your IP address, then the network portion of that IP address will be all 1 like this, and the rest of the part will be 0. All right, so for class A, obviously our network portion is fast 8-bit. So all fast 8-bit will be 11111, and the rest of the part will be 0000, right? So whenever you convert it, whenever we convert this number all 1 into the decimal, we can find it is 255. Okay, because that is the maximum, and the rest of it 000. If you think about the class B, we know that the first 16-bit is the network portion, and the rule is all the network portion of the IP address should be 1, and then the rest of the part will be 0. So if you put all 111 in 16-bit, so we have, as again same way, 255.255.0.0. So that is called mask. Default mask or subnet. Okay, subnet mask is different. Whenever we are doing subnet mask, then it will be subnet mask. Now it is just a default mask. You may ask the question that what is the reason why we need to find a mask? What is the responsibility of a mask? There are so many other responsibilities, but the main responsibility is to find out what is the network address of an IP address. Generally, if you look at any IP address, sometimes it is difficult to find out that what is the network address. So, but if you know the default mask, it will be very easy to find out that which one is the network address. It's very It is very easier that okay, this is class C, so obviously the first three portion will be the network address. You are correct, but whenever you are using the subnetting, it is not that much easy. So this is just a basic rule. This is just a basic rule. By using this basic rule, we can apply this basic rule in any other scenario. All right, whatever scenario we are showing, maybe it is very simple, because without doing any kind of thing, we can easily say that the first 3 bit is the network portion. You are right, but this is just example, and this is just a technique. By using this technique, we can find any network address of any number, either it's class full or classless or whatever. So what is the technique is? The technique is, if you convert your IP address into binary, and if you convert your subnet mask into binary number, and then you add them together, binary addition, and the result will be your network address. That is the technique. So you have to convert your IP address into binary address or binary number. You have to convert your subnet mask or mask into the binary number, and then you add them, of course, binary addition, and the result will be your network address. If you think about this address, this is our address, this is our mask, and if you add them, of course, binary addition, we have our network address. Okay, again, I'm telling you that it is very easy. Without adding, we can easily identify that this is a class C address, and the first 3 will be the network address. Yes, but this is just for an example. Whenever we are going to have a subnet mask, that will not be that much easy. Let's say, for example, I show you that /27, right? /27 address. This is also class B address, but you cannot find the network address that easily. You cannot say that network address is this. We need to find the network address by that way, because it is 27 bit. How are you going to find the 27 from here, from the decimal? Is it possible?
No, sir.
You have to convert it into the binary,
Binary.
bit by bit,
Yes.
bit by bit, and then you can add your subnet mask with it, and then you can have your network address. Because in the decimal number, we cannot calculate the 27 bit with the decimal number. So you have to convert into binary, and then we will do our calculation. So in that case, we will need this technique. We will need this technique. Okay. So that is the